Here are some starter questions. Question number 1. Express 3 sin x plus 2 cos x in the form r sin x plus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. Number 2 follows on from that. Find the greatest value of 3 sin x plus 2 cos x to the power of 4 and state the values of x for which they occur. Question number 3. Simplify 2x squared plus 9x minus 5 over x squared plus 2x minus 15. Question number 4. Given that log of 2x squared plus 9x minus 5 equals 1 plus log x squared plus 2x minus 15, x cannot be equal to minus 5. Find x in terms of e. Pause the video now and give it a go. So, I'm going to give this a little go now, answering question number 1. So, this needs to be written in this form. So that's what I'm going to write down first of all. 3 sin x plus 2 cos x must be equal to r sin x plus alpha. So the addition formula for this is sin x cos alpha plus r cos x sin alpha, and then I'm going to look at the coefficients, and the first coefficient I'm going to look at is the coefficient of sin x. So here's the corresponding sin x there. So 3, which is the coefficient, is going to equal to r cos alpha. 3 divided by r equals cos alpha. And then I'm going to look at the coefficient of cos x, and then there's the cos x over here. So 2 is the coefficient, and that is going to be equal to r sin alpha. Divide both sides by r, 2 over r equals sin alpha. Now there's a number of ways we can solve this to find out what r is and what alpha is. My preference is to draw a right angle triangle involving alpha. So cos of alpha, there's my angle alpha, is the adjacent over the hypotenuse, the adjacent over the hypotenuse, and then sin alpha is the opposite over the hypotenuse, the opposite over the hypotenuse. So r we can find using Pythagoras' theorem, which will give us root 13. And then alpha, I'm going to use opposite over adjacent, and that will give me, using my calculator, 33.7 degrees. So there's my answer to question number 1. There's r, there's alpha. Question number 2, find the greatest value for which this occurs, and it's to the power of 4, and the corresponding values of x. So root 13 sin x plus 33.7 degrees to the power of 4. So this expression, what's the greatest this can be? So for sine, we know the maximum is going to be 1 times by root 13, gives us a maximum of root 13, and that's taken to the power of 4. So the maximum value will be root 13 to the power of 4, which will be 169. And then we need to find x values for which this will occur. I think I missed it off in the question. Did I say, oh, so between 0 and 360? I didn't have that in the question. So you may have found more, you may have found less. So I'm going to set this maximum value equal to the expression and find out the values of x that make it equal to 169. So 4 through to both sides is root 13. And then divide through by root 13 gives us 1. Arcsine of 1. So where is sine equal to 1? And that occurs at 90 degrees and at 270 degrees. So x plus 33.7 equals 90 degrees and 270 degrees. Take 33.7 off both of those answers and we get 56.3 and 236.3 degrees. So sorry I missed off the range in question number 2. Okay, on to question number 3 now. We want to simplify this piece of algebra that we have. Let me just come back down a second. So question 3, question 4 are linked. So simplify this. So the first thing I'm going to do is to factorise both of them. So take that numerator, 2x squared plus 9x minus 5, product of 10 and a difference of 9, 10 and 1. So x plus 5, 2x minus 1 is what that factorises to. Now the denominator, x squared plus 2x minus 15 will factorise to x plus 5 over, x minus 3. So we have x plus 5, 2x minus 1 over x plus 5, x minus 3. So that gives us 2x minus 1 over x minus 3. There we go. So there's question number 3. Done. Hence or otherwise, we have this equation, log of 2x squared plus 9x minus 5 equals 1 plus log x squared plus 2x minus 15. So the first thing I'm going to do here is to put the logs on the same side of the equation. So take away this logarithm make it equal to 1. So the laws of logs, when we take away logarithm, they become a quotient, they become a fraction. Now that is the same fraction we had in question 3, so I'm going to replace this, which is that question from 3, with the 2x minus 1 over x minus 3. So we have got log of 2x minus 1 over x minus 3 equaling to 1. Raise both sides of the equation to the base e. E to the 1, e to the power of 1, or just e. 2x minus 1 equals x, e or ex, minus 3e times by the denominator. Take the x's to the same side, so let's take them to the left-hand side. 2x minus xe equals positive 1 minus 3e. Factorise x out, 2 minus e equals 1 minus 3e. Divide both sides by the bracket. X equals 1 minus 3e over 2 minus e. And we have written x in terms of e. We found the value of x, but leaving it exact in terms of e.